Hello guys, my name is Vlada, and in this video we will see some theoretical aspects of line integral of scalar field. Line integral of scalar field. Okay. First, what is scalar field? Scalar field is nothing else but some function f from a real n-dimensional space to a real line. In this video I will be particularly interested in functions from R2 to R and functions from R3 to R. Okay. Now, what is line integral of scalar field? We will divide this on two cases. First case will be two-dimensional case, and line integral of scalar field is notated something like this in 2D case, where this means integral over some curve L, and curve is in the real plane. Okay, this is our scalar field, two-dimensional scalar field, and this object here is called the line element. So this is line element. Okay, sorry, line element, and this is a scalar field from R2 to R. Okay, let's proceed to three-dimensional case. Okay, we note 3D line integral in this fashion, and this is also notation for integral over some curve L, and curve is in three-dimensional space. This is our scalar field, three-dimensional scalar field. Okay, from R3 to R, and this is line element. Okay, scalar field is multiplied here with line element and here also. So these objects are pretty much abstract at this moment, but there are some steps that can be done in order to reduce these kinds of integrals and these kinds of integrals to just an ordinary integral, yeah, from A to B, and some function in that ordinary integral. So let's see that steps. I will divide 2D and 3D case. Okay, this nice. I enjoy drawing these lines. So let's see the first step here. First step is to parameterize curve L. Parameterize curve L. And actually we are parameterizing our variables x and y. They will depend on some t, some time variable t, okay, sorry, brackets, and y will also depend on the same. T and t will go from A to B, where A and B are real constants and A is less than B in 99% cases. So let's see three-dimensional case. Very similar. We only have one variable more. Okay, first step is to parameterize curve L. Okay, x will depend on t, y will depend on t, and z will depend on t, where t goes from A to B. A is less than B in 99% cases. A and B are real constants, are I permuted this and this here, but it doesn't matter. Okay, second step is to calculate line element. Calculate line element, and this is line element, this little thing here. ds will be equal to square root of derivative of x respect to t squared plus derivative of y respected to t squared times dt, and this dt is outside the square root. Okay, and let's see second step in three-dimensional case. 3D case, calculate line element. Okay, this t is not really a nice t. Okay, this is our line element, and it's equal to square root of derivative of x squared plus derivative of y squared plus derivative of z squared times dt. Dt is also outside this square root. And our third step is to plug in everything that has been done, sorry, in first two steps. Plug in. So our integral over curve L of f times ds will be equal to ordinary integral from A to B. Function f is here, and that function now depends on t times ds, and ds is this square root of x derivative of x squared plus derivative of y squared times dt. Okay, this is our integral that we have to solve, and our problem, our line integral problem, is reduced to this problem, solving just one ordinary integral. Okay, is everything okay? Yes, it is. Everything is okay. Now 3D case, I will need more room here. Integral our curve L of f times dc is equal to ordinary integral from a to b of function f that now depends on t times ds square root of derivative of x squared plus derivative of y squared, okay, squared plus derivative of z squared times dt. So let's just go back at the beginning to see what we have done in this video. First, we have introduced scalar field. Scalar field is a function from n-dimensional real space to R, and we were interested in functions from R2 to R and R3 to R. This is a notation for a line integral of scalar field in two-dimensional case. We had scalar field, two-dimensional scalar field and two-dimensional line element, and here we had scalar field of three-dimensional scalar field and three-dimensional line element. This is three-dimensional case, and the notation for line integral of 3D scalar field. And steps were, first step in 2D case was to parameterize our curve L with some parameter t, and here in three-dimensional case similarly, but we just had one more variable. Second step was to calculate the line element ds, and this was formula, this was formula, this is formula, whatever. Plug in everything. We plugged in our parameterized variables x and y. So on right side we have an ordinary integral from a to b of function f that depends now on t, and this was ds, our line element from step 2. And similarly in 3D case, right side is ordinary integral from a to b of scalar field f that now depends on only one variable t, and this is ds from the second step. So this is everything that I wanted to say in this video. In next video we will see some examples some problems and we will solve that problems. So bye bye.